right. So yesterday we were able to um, cover the cover the Spark advanced operations and running on the cluster, right? And okay, a question from Raju is, can you please share the yesterday's presentation link? Also, those who are not aware, if you go into the class, this particular one, if here, let's say you want to take a look at this particular presentation. Okay, you could take a look at it, say, not this one doesn't have a presentation. So let's say advanced Spark programming. So you could actually take a look at the slides in that particular topic. All right. For any topic in past, you could take a look at from there. All right. For today's session, I'm going to share here because you may not have time to go uh, the into the details. So I'm going to share the presentation. These presentations are confidential. So if you are sharing with somebody, just let us know before. All right. A question from David is, a lot of time the screen turns gray and you cannot download. Okay. Do you mean that from here you cannot download this one? I see. Okay, so what I'll do is we have the full folder of PDFs. Okay, I'll share the full folder of PDF. Here you can download. You can see if you just click on the PDF versions, you can actually download. So if you open it here, let me just see if I'm able to open from the incognito window. All right, let's see. All right. So yes, in this one you can download, as well as let me just check if you are able to, let's say we are in this particular project, and here there is a link here which opens it there. Okay, so in general you should be able to access it. All right, similarly here. Okay, and all right, so I've given you the PDFs for the last session, yesterday's session. Similarly, running on the cluster and running on the cluster base, running on the cluster, Spark on the cluster. All right. So if sometimes the slides are not in the beginning, I'm also updating them, putting the slides in the beginning itself. There, generally the slides are in the last topics. Okay, so I'm going to. All right, this is not right. Okay, so yeah, the URL is right. The text is not. Okay, so all right, so great. Let me just fix it right away. Okay, so not, this is running on the cluster. Great. So all right, wonderful, wonderful. So I hope you will be able to access these PDFs from here. In case you're not, please let me know. And that was yesterday's presentations. Okay, so let me hide this. Great. And so what we are going to discuss today is, first we are going to discuss Spark Streaming. Once Spark Streaming is done, then we are going to start with data frames. All right. Then we are going to start with data frames. Data frames is broken into two chapters because it was becoming too much for Google Docs to handle in one presentation. So That's why we broke the data frame into two parts. All right, so today's sessions are going to be super exciting and quite useful for all of us. And it's going to be quite hands-on. So if you are logged in from tablet or if logged in from the mobile, keep the laptop nearby so that you could do the hands-on with us. Great. So is there anybody who needs the permission to record? I can give it right away, and then we can start. All right. Okay. So David, was I able to answer your question? A lot of time the screen turns gray and at least I can't download. Okay. So, okay, I need to understand where the screen turns gray. This is something very important. Okay, like the server is busy. All right. Okay, let me just make a note of it so that I can debug these issues. Because here what we have done is, since we needed different kind of experience in the sense that people should be able to do assessments and other things, we have built entire thing from the scratch, and that's what has taken a bit of user experience. We are still trying to make it useful to all of us, and therefore I would love to debug this issue. The more information you could give it to me, the better it would be, the more useful it would be for me. Okay, so great. And this one, yes, please. That'll be wonderful. Yes, go ahead. Please go ahead with sharing the screen. Okay, okay. So here, this is turned gray. I see, I see, I see. And if you press shift or anything, it doesn't look nice. Okay, okay. But do you face this kind of issue when you're using Chrome? Is this Chrome? Ah, I see, I see. Can you click anywhere, press escape or refresh? All right. Oh, okay. Okay. Is there something else going on here? So if you say, can you take the cursor to the refresh button above? Nothing is working there. Yeah. Okay. Now it's working, but if you click some link or something, then show me how what happened. This time it worked. Okay. But sometimes it's causing that, right? How did that happen? The previous thing? Now it seems to work, but it's kind of click that. Yeah. Okay. Ah, I see. I see. I think this was super useful. Let me just press escape. Press escape. Is there the only solution there seems to be the refresh. You are on Windows, right? Let me just note it down. I think Windows. Okay. And Windows 10. All right, let me just debug this issue. Windows 10 and using Chrome on Windows 10. All right, all right. So probably I think, okay, Elvin too faces the same problem. Okay, and May 1st, will it get extended till the last class? Yeah, I think so. I had increased the subscription for all of you. Okay, what's your email ID, Grisma? Okay. Okay. So, question from. Okay, great. So, David says that same thing happens if I step through each of the screens and not just jump to the last. Okay. Can I take a look at that one? So that will be great because this is getting recorded, so I can share it with my other team members and show them that these are the problems and get it fixed maybe tomorrow or in the night. Okay. So here the dialog box is still open and everything is disabled. Okay. Okay. I see. I see. All right. All right. I think this is good enough for me. This is very good. So Alvin, you also face the same problem. And what OS do you use? Okay. And which browser is it? Okay. Okay. Great. Great. And yes. So Grisma, I think uh, I had increased your extend the lab, right? So I had extended the lab, but I need to take a look at what happened. Okay, so just check if the end date does it still show you the end date is end date is 1st May. Okay, all right. So I'll just get it fixed. And these are super useful feedback. And because when we are looking at the screen activity, we are not getting these points. And okay. And okay. This is important. So, okay. For David, the Unix is still at 99%. All right, this is something I'll have to figure out after this session because I was also stuck at 99%. Then I went back and tried to fix those, and then it worked well. Okay, so there were one or two things left in my case, but okay. So let me just make these notes, and yeah, wonderful. So. All right, so I'm going to take a look at these to-dos before tomorrow. Great, great. Subscription end date should be, I think, somewhere in the June, probably the end of May or something like that. All right, I'll just take a look. So, yeah. Subscription end date must be beyond end of May. Okay, so that is something that I have to ensure. Subscription end date should be beyond May. All right, so this is another point. Thank you, Bintao, to let me know. Right. Question from David is that thought there were lifetime access, correct. So the videos and the content that you see here, the content that you see here in case of, all right, let me just show you that part. So if the videos that you see is lifetime, while the lab, as in the access to the lab, is limited. Okay. That is something it's hard for us to provide lifetime because we pay huge fees to Amazon and other players for the lab. So the lab is limited while content access to the quiz and other parts of the content is free and for lifetime. Good, good. So, all right, wonderful, wonderful to have all of you in the session. So let's get started with a new topic today. So far, what we have learned with respect to Spark is that we can churn or process humongous data using many computers or many cores on the same computers. And how do we, so far we have learned how do we distribute the logic by breaking it down into map, reduce, flat map, and other transformations and actions. So far, we have learned how to handle the batch-wise process, right? All right. So far, what we've learned is how to handle the batch-wise. What does it mean by batch-wise? Batch-wise is something that you submit or execute, it works, and then finishes the work, right? Now, that is called batch-wise, while the other kind of processing is called streaming. Streaming is nothing but doing work continuously. This is a topic that really I am very close to my my core interest, and and I've worked on with Amazon to build a framework for doing the stream processing. All right, it wasn't as big as Spark Streaming or it wasn't as big as Storm, but it is being used by around 10 different projects inside Amazon for doing the stream processing. All right, so I'm going to go into the details of Spark Streaming and the stream processing. So I'm talking about the stream processing. So I'm going to talk about that in a while. So usually whatever we've done so far is we pressed enter, right? Executed something, that execution finished, and then we got the results. That's what we have done so far in most of the programs, right? That's how we look at a program, that when we run a command, it does something, it ends, and then we get the results. But those were the batch-wise operations. Those are called batch-wise programs or batch processing. The other kind of processing is stream processing, where the processing never stops. The program waits for data to come, processes the data, puts in the output, and then again waits for the data to come. So these kind of programs never end. They behave like server, they behave like services, they never end. They keep on waiting for the data continuously 24/7. So that these kind of programs are called stream processing programs. All right. So stream processing, where did I work on? I worked on handling the large amount of changes that happen on the Amazon's detail page. And based on those changes, we were updating the big image that you see on the left top, the big image, that's called the product image on the product details page. So every time there is a change on the Amazon's detail page, which is done by either the supplier, vendor, or internal product team, like we uploaded some more images, resized existing images, or graded a particular image with certain rank. Based on any of the detail page changes, we do the selection of the product detail page, the image of product detail page. So we do the selection of the product detail page at Amazon. So that's kind of thing we did. So my program used to observe the changes that are happening to the product detail page of every product on Amazon.com. At Amazon.com, there are many products, and whenever somebody is making a modification to the product, like somebody changing something, we receive a notification and we keep on observing the notifications. And whenever we receive such notification, we re-rank the image, because every product detail page has many images for the product, right? So we have to select one or two images that need to be displayed at the left top. And we observe that we basically keep on showing, we basically select one image out of so many images for every product that is being changed. So those are the kind of things that I worked at Amazon for a couple of months, where I built a framework, a generic framework which could handle such kind of notifications and could distribute the work across the Amazon. And that kind of became quite useful to other teams as well, not only for image selection, but for others also. So, so that's what, that was my, one of the very deep interaction with stream processing at Amazon, right? Because we were handling it using around 60 to 70 servers, and I brought it down to around 20 servers. Okay. A question from Mohammed is, we are going to do our image resize project, right? Yes, yes. Okay. You also try to think of it and see if you can also come up with some ideas. I have I have put I have put some images in /data/images. There you can take a look. All right. So I'm going to discuss that project probably later, and then we'll see that. Okay. All right. So let's start with Spark Streaming. I'll give you a little bit more details about it. So Spark Streaming is an extension of core Spark API. It enables stream processing, and it is scalable. It has high throughput. I'll just close it because I find it very irritating. Okay, so Spark Streaming is an extension of the core Spark API. It enables stream processing. It is highly scalable and has high throughput and has high fault tolerance. All right. So what does each word mean? Each word means that, okay, let me just go back to what we were talking about. So Spark Streaming essentially makes it possible to process the data continuously 24/7. Instead of processing the data and then exiting, it runs forever. It runs forever. So it is scalable in the sense that today you are having 1,000 data packets per second. Tomorrow, if you have 10,000, then also you can handle it, right? And high throughput, as in it gives you really high throughput, as a number of requests that can be handled by it are really high. Second, it is fault tolerant. What does it mean by fault tolerant? In case one of the machine that was involved in doing the stream processing, if that dies, it should still run on some other. All right. So okay, let me just share the. Okay, so I'll take the questions after this topic, but that doesn't mean that you don't ask questions. Okay, so all right, I'm going to do it this way because there's some animation that I don't really like. Great. So I hope this is very clear to you. So basically, Spark Streaming is an extension of core Spark API, and it enables stream processing. Now, what does it mean? Spark Streaming consumes data from various continuous source of data. What is continuous source? Or sometimes we call it unbounded source of data. Or stream processing, the term stream processing refers to processing stream which is continuously coming to you. And the term stream processing sometimes is also referred as unbounded processing or unbounded data processing, meaning the incoming data that is being processed is not having any boundary. Therefore, therefore, Spark Streaming needs a data source which is continuous and such as Kafka. So if there is data lying in Kafka, you can process using Spark Streaming. What is Kafka? Kafka is a big pipe. You can think of it a pipe whereby you can put data on one end and can be consumed on the other end. That is Kafka. In Kafka, you can basically push data from all places and read from the other end and consume and convert that to anything else, right? So basically, Kafka is a queue. Okay, do you want me to give a quick overview of why Kafka is used, right? I think I'll just take a bit of digression that will be quite useful to all of you. I'll just draw something here. All right, let's take an example of Amazon. Okay, let's take an example of Amazon. Amazon has a team called fraud detection. Okay, there is another team called delivery. There's another team called availability. There is another team called say email, right? Now, as soon as somebody is making a purchase on the website, right? Somebody is making a purchase on the website, all of these teams need to be informed. Okay, so let's say this is website. Now user is making a purchase here. This is a retail website. And now it needs to inform to all of these people. Correct? Now the purchase could happen from the website, or purchase could happen from the app, or purchase could also happen somewhere else. Okay, so they all need to be informed. Okay, if website has 10 different pages, like one is buy now, other is add to cart, and then checkout. So there could be like there could be multiple checkout buttons, and there could be multiple things. Now, every time there is a newer team, they will go back to saying, hey, website team, can you subscribe me also to your notifications so that we can also take an action. So every time you make a change, a new team comes up, they will go and ask the website team that, hey, can you also inform us when something interesting happens. So user went here, website user purchased from here, and website informed all these teams. So similarly, email team also need to inform and things like that, right? Also, when availability people are updating something, a product, the various component in the company needs to be informed, like we were doing when say there's a catalog team. Okay, there's a catalog team. So catalog team was supposed to update the website. They will update the catalog. Now, some of the teams would like to be updated. Now, how would catalog team know that who wants to be updated? It's really difficult to let's say there are teams like availability. They want to be updated whenever something changes in catalog. Soon enough, you will find that there are notifications which are impossible to track, right? Everybody is holding their own subscription list, and everybody is trying to notify each other. And how will they notify? How will website team notify email team? By calling their like webhook, or calling their some kind of website or what? So it becomes really difficult to make the calls from website to all of them, right? So instead of this kind of model, what companies like Amazon do is, any organization does is, they create they create something called an organization queue. They create something called an organization queue. All right. So instead of people talking to each other, they have an organizational queue, right? So in this organizational queue, they can write to a particular topic. So it has many topics in it. This is one topic, there could be another topic, and there could be another topic, right? So website team could speak on its topic, and everybody would listen to the topic. Everybody listen to the topic. Similarly, catalog team might be speaking on another topic, and there could be other people listening to it. So listening is the problem of the listener, right? Not the catalog team. Catalog team does not need to know that who all wants to listen. So we decoupled the producer and the consumer. In this case, these guys are producers, right? There could be certain cases where availability guys are producers. Let's say they want to inform everybody that the product has been out of uh, out of stock. So maybe some other people would like to listen to such kind of events. So this is essentially the publisher subscriber model. Thank you, Hitendra. So basically, when you want to explicitly call certain services, then you use the API or service calls. We call them service calls, right? So let's say in companies like Amazon, or what they have done is, they have actually, instead of people talking to each other and getting the access to each other's databases, in large organizations, what people do is they own their own services, and people make the call. So if something active needs to be done, then people can call their API. But if they want to be informed, they want to inform to each other, then we want to use the queue. We want to use the queue. All right, we want to use the queue. Thank you, David. Yeah, that's similar. And this is called, in Amazon, we use SQS. Other people use Kafka. Some other people used to use, there is Oracle's queue, which is essentially a database table, and so on. So this queue that you see, this big pipe, there are many people talking on a topic and other people listening on a topic. And this is called, they basically standard publisher subscriber model or producer consumer model. All right. So you can see that this is the one that I optimized and built my framework on. So essentially what we did was, we listened to a topic and we execute the programs. Now, where does the Spark Streaming fit here? Spark Streaming is just one consumer of this queue topic. So our Spark Streaming programs, what they do is, they listen to a topic of Kafka or any other such resource. Okay, any other such resource. So this is basically what it means by publisher subscriber model. All right. So in these cases, what we'll have to do is, whenever we want to listen to a topic, we'll have to listen on a topic continuously. You never know when the event happens, right? For such kind of listening, such kind of 24/7 listening, we create streaming application. All right. The streaming is heavily abused term. Streaming is also called when you want to stream a video, as in you want to play a video on user's screen. That's also called streaming. And stream is also passing the data through a particular filter, like Unix SED. There is a command called SED in Unix, which basically does the filtering of incoming data. So, and Unix pipes are designed in the similar producer consumer way. And so SED, for example, is basically processing the incoming stream, right? The Hadoop streaming, right, is not what Spark streaming does. Hadoop streaming is nothing but a way to execute batch process using some other program than Java. All right. So Hadoop streaming is not equal to Spark streaming in any way. Similarly, video streaming is not equivalent of Spark streaming in any way. But Spark streaming is essentially processing data continuously, which is coming from an unbounded data stream. All right. Now, so
The streaming
yeah,
means bytes. We can say
right.
byte.
Come again.
Streaming means bytes of data.
Not really bytes. It could be an object. It could be a file. It could be a small binary packet. It could be anything.
We can say flow of data.
Flow of data. All right.
Okay, thanks.
All right. So basically, the data could be in any format. The data could be like a small file. Data could be like a small object. Data could be incoming, it's binary data as well. So data could be anything. All right. So it is between you, it is basically an understanding between you and the producer of the data, that you need to understand the format or agree upon a format between you and the producer. All right. Great question. So moving ahead. Now, the Spark streaming is a wonderful library. It is basically a extra library on top of Spark. What it does is it consumes data from not only Kafka, but also from sources like Flume. What does sources like Flume do? Sources like Flume basically create, what is Flume? Flume is Hadoop's way of copying data continuously from all the sources into HDFS. Right? So on one end, Flume could be pumping data to HDFS, and on the other hand, the Spark streaming would be consuming that data that is being gathered by Flume, right? Similarly, Spark streaming can monitor a particular folder in HDFS, as in when you are adding more and more files, it can process those files using Spark. The third thing is ZeroMQ. ZeroMQ is very similar to Kafka, just that it is very efficient and designed for in-memory queues. Okay, so if you are building a large application and you want your components to talk to each other via publisher subscriber model, then you generally use the ZeroMQ or ZMQ. ZMQ is quite powerful and popular in the application design. So ZeroMQ is another queue-like structure, just like Kafka. And we have, similar to that, we have Twitter. Let's say what you want to do is you want to process the tweets in real time using Spark. Then you can use the Spark streaming. Twitter gives you sampled data, meaning a small subset of the total data. For free, but if you want the Twitter host, there is something called Twitter host, then you'll have to pay a huge amount of money to Twitter for that data. All right. So question from Binta is, what's the difference between Scoop, Flume, and Kafka? Scoop is batch-wise. It copies the data from SQLs to Hadoop, right? or vice versa. So it's a batch-wise command to copy data from one place to another, outside Hadoop to inside Hadoop, or inside Hadoop to outside Hadoop. That's what is Scoop. Scoop is basically Hadoop jar or MapReduce command, which basically optimizes the data transfer. And that's batch-wise, so it's not really stream processing. It basically does the job, finishes the job, and exits. No, it doesn't do it continuously. That's Scoop. Flume is continuous. The only difference with Flume and Kafka is Flume is continuous in the sense that it carries the data from all the places to centralize data lake, such as HDFS. So Flume is unidirectional flow of data to a central place from everywhere. That's Flume. Now in Flume, you can have various kinds of sink and sources. And then we have Kafka. What is Kafka? Kafka is the queue that we discussed, in which anybody can be producer and anybody could be consumer. So all right. So Flume is essentially a way of copying the data continuously from many places to a central place. Okay, that is Flume. While Kafka is a publisher subscriber kind of a model in which there could be many writers, there could be many readers. All right. I hope that answers your question, Abinta, and Hitendra also. A question from Sachin is how Spark Streaming stores data into HDFS. We'll talk about this. So Spark Streaming would be processing incoming data from all these sources, and it can write data into HDFS, databases, and dashboards. All right. So it basically can write to all these destinations. So let's say you want to process incoming data from Kafka and you would like to keep on saving it in HDFS periodically. So you can use Spark Streaming for the same.
So Sandeep, Spark Streaming is a component or an application of Spark, or it is come with Spark?
It's a library of Spark.
It's a library of Spark. We have to import it while.
Yeah, so it's an extension, and we'll have to run such application continuously. So you will basically do the Spark submit, and it'll start running continuously. This program will not end. All right.
Okay.
The only way you can end such programs is by killing them. Otherwise, they don't end. All right. The other question that a lot of people have with respect to stream processing is that when a program does not end, then how do you test it? Right? Usually, when we have like normal programs, what we do is we run the program, we wait for it to exit, and once it exits, we check the destination, whether it has done the work or not, and compare it with your expectation. Correct? That's what you generally do in case of when you want to test. Now, how do we test a Spark streaming? So what we do is we design the programs, or whenever we whenever we are doing this streaming, we will have to design it such that as and when the input contains a particular packet, we need to design a poison, and when the poison is there in the input, we have to gracefully exit. Okay, so as soon as we observe the poison. So that's the idea behind. We'll observe that later. All right, that's how we do the testing. A question from Robin is, what is the command to kill Spark Streaming? Spark Streaming can be killed in the way any process can be killed. So we can use the yarn command from the console to take a look at running programs, or use the kill command from the Hue. There is a button called kill in Hue. When you are running a continuous process, you can use that. All right. So I'll just go into the usual mode. This is better for me. All right. So how does Spark Streaming work? The way Spark Streaming work is we have input data stream. that goes to Spark Streaming. So Spark Streaming is a library that receives the input data from the input streams. Then it breaks down this continuous data into the batches. So you can think of Spark Streaming as if it's a large for while loop, infinite while loop that why keep on reading infinite loop, which is reading the data, creating the batches, and putting in the output. And these batches are then processed by Spark Engine using your code. All right. Now, the Spark streaming receives input data stream. The input data stream could be Kafka, Flume, HDFS, 0MQ, Twitter, and many more. And using Spark streaming, we break it down into batches, and then these batches are saved at destinations such as HDFS, databases, and dashboards. Now you can visualize it this way. So you can see there's a liquid that is coming in, and we are creating bricks of that uh, um, cream into ice cream sandwich, right? So these are batches, and this is the continuous incoming data, and this is your Spark streaming application. So Spark streaming, this is what it does. Spark streaming takes the input data, creates the batch of the size that you wanted, and then on each brick, we can run our program as if that brick is your incoming data. On that brick, we can load that data into an RDD and then process each of these bricks using our usual uh, transformations and actions. Okay, I hope this is clear. So this is what Spark Streaming is doing. This is an incoming flow of continuous data is being broken down into the bricks. All right, so we are going to take a look at Spark Streaming application very soon, Sachin. Now, so this is how you can visualize your Spark application. Now you can think of this machinery, it'll keep on running whether there's incoming data or not. The only optimization we have is it'll wait until there's an input cream coming in. Okay. So in the same way, we have the Spark streaming. Now let's talk about use cases. The first use case is the real-time analytics. Say, say for example, you are an e-commerce company which is receiving the data, which is receiving a lot of orders on the website. So imagine that you are a e-commerce company, and this we did for Dell. Dell sells laptop on their website, and they wanted to observe. They wanted to observe how many orders are being shipped every minute in a dashboard. So they wanted to update this graph as and when data comes. So this is called operational intelligence, whereby our operations team is observing these graphs continuously and comparing it with, say, yesterday and what was happening 15 days before and what was happening in the last quarter or last year. So we could observe how we are performing today at this very instant as compared to day before yesterday. All right. So it gives you the real-time analytics, right? So the idea of a dashboard or real-time dashboard comes from the dashboard of a car, right? Whereby you have the speed, the speed and the current distances and everything updated in real time. There is no refresh, or there is no refresh that you get the instant data in case of car. And that's the idea which we want to build in case of real-time analytics. We want to update the data as and when the input data changes. So this is basically a use case of Spark Streaming where you want to give real-time analytics, just like car's dashboard. A question from David is, is this graph showing that roughly $33,000 orders are being shipped? So actually the simulation that we built was designed for that kind of load handling. All right, load handling. So this is basically based on the simulated data, not the actual data, but they said that you should expect this kind of traffic. Okay, so so the inflow of inflow of the data was something that we designed ourselves so that we could pump really fast. And today we'll do that we will simulate aggressive stress testing on various things. Okay, so yes, this is essentially part of the stress testing. Those who are not aware of stress testing is testing your application, how much how much load can it handle. All right, so today we are going to show you that we can actually handle couple of million record in a minute. Okay, um, mm, of and more. And we will see that now. The now in the real-time analytics, the problem statement generally is to build real-time analytics dashboard with information on how many products are getting purchased, shipped, and delivered every minute. So there could be many more than this. All right. So in real-time analytics, the input stream of product status is fed to the Spark streaming. The entire stream that is coming from, say, e-commerce website, continuously what all is going on the website, that comes as a continuous stream of packets. It could come from a log file which is being generated by the web server. It could come from other sources. Say, for example, in our case, this was the feed that was coming to Spark Streaming. There was the, the item ID or product ID followed by the status, whether it's purchased, shipped, or delivered. Now we wanted to break it down into per minute, and then our engine was processing it and representing each block, each 1 minute batch at a time. And then after processing each batch data, it was representing it as a nice graph and showing exactly total count of the items. Here it's per item based. Here it's basically how many of such events happened in a minute. All right. So all we needed to do was do the group by on the status. All right. So all we wanted to display is the overall statistics per minute that's happening on the website. Okay, it's an e-commerce website. It's an e-commerce website, and what we are getting is these events that this product got purchased, this product got shipped, this product got delivered, and so on. And we wanted to display how many total were purchased, how many total were shipped, how many total were delivered. All right, is it clear, Sachin? You could ask a specific question. So this is our input, and this is our output, expected output, and rest of the magic is done by Spark Streaming. All right. So all the events that are happening on the website, we were receiving that as the input stream, and our engine was processing that input stream and representing it in terms of the statistics per minute. A question from Grishma is that purchased will be for particular time span, right? That's right. So here, this purchase would happen at a particular time and so on. Okay. Yes, it is very much possible to do the same thing per hour or per minute or per second. Okay. That's something that we're going to see. All right. So you have incoming events from an e-commerce website telling you that that this is what is happening. This product got purchased, this product is shipped, this product is delivered, and so on. And then we need to show the statistic. That's the problem statement. Sachin was able to explain the problem statement.
Yes, yeah.
Okay, great. Moving ahead. Now, the other example of use case of Spark Streaming is the real-time sentiment analysis from, say, Twitter or from any other social media. So on one hand, let me just rephrase the problem statement. To build a real-time sentiment analytics, to find out the sentiment of the users every 15 minutes or so by analyzing data from various sources such as Facebook, Twitter, users' feedback, comments, and reviews. Okay, so Spark Streaming consumes data from Facebook data, Twitter data, users' reviews, and then every 15 minutes, okay, so Spark Streaming will consume the data from all these sources and break it down into 15 minutes batches of input data, and then Spark Engine will process and give you the sentiment, whether people are liking it or not liking it, negative or positive. The third use case could be, these are some of the use cases, though streaming is used in many more cases than you can imagine in organizations. Stream processing is used in many more use cases. So the next use case is to build a real-time fraud detection system for a bank to find out the fraudulent transactions. So the input stream of bank transaction is coming to you. Then the Spark Streaming is basically breaking it down into 1-minute batches of transaction. Spark Streaming is processing each batch using, say, a machine learning algorithm, say machine MLlib, and it is basically a trained model to detect the fraud. And our engine is basically using this library to check whether a particular transaction is fraud or not. And after it is done, it'll send it as a report, or it could be sending as a it could be putting this output back into Kafka queue so that the transaction stream could listen to a particular queue and take appropriate action. All right. So Uber, who is using such kind of system? Say Uber is using Spark Streaming for real-time telemetry analytics. What is telemetry analytics? Real-time analytics on the trajectory of various cars. Okay. Is my voice breaking for anybody else? I'll switch my internet if it is so. Okay, for Mohammed and Sachin, it's breaking. And it's not breaking for David, Alvin, and Shravanti. All right. So I think should I just give it a shot? The another internet connection I have, and then we can decide. Are you able to hear me clearly and see my screen clearly? I'm just moving my cursor. All right. Great. Great. So I have just shifted my internet connection to another, and I'm hoping that the voice will not break now. Or is it breaking? Does it sound okay?
Yeah, Sandeep, Spark Engine is nothing but Spark or
Yeah, it's Spark only.
Spark only.
Right. Okay. Thank you, David, for letting me know that actually, yeah, fan was too high. That was probably making too loud sound. Great. So moving ahead, and here we go. I hope the noise is less now. All right, so Uber uses Spark Streaming for real-time telemetry, and Pinterest uses Spark Streaming to provide immediate insight on how users are engaging with pins across the globe in real time. Netflix uses Spark Streaming to provide movie recommendations to users. And the core concept in Spark Streaming is DStream. What is DStream? DStream is essentially discretized stream. There is something called structured streaming. We'll talk about that later. And so Spark Streaming is basically around something called DStream. What DStream does is whatever is the inflow of data, it breaks down into the batches. And for each batch of data, it creates an RDD. And this RDD is nothing but what we studied earlier. This is another RDD, this is another RDD, and so on. All right. So all we are doing here is breaking the input data based on time into the RDDs, and we're processing RDDs using our standard Spark engine. All right. So that's what it is. So David's point is that in the class up to now, everything was not real time. That's correct. Almost everything was the batch processing. If we want to process data continuously, then we would like to use Spark Streaming. Also, please note that if you are looking for lesser than 1 second of response time, then you should use, say, Storm. Spark Streaming is great for a window window of more than 1 second. So DStream represents the continuous stream of data. It can be created from input data streams, all kinds of input data streams, or from other D streams. Is represented as sequence of RDDs internally and is used to write Spark streaming programs. All right, now let's try to, okay, a question from David is, can you repeat this Tom comment? Yeah, I'll come back to that later also, but let me just repeat what I said. Spark Streaming creates batches on time window. The data is coming, and for every second or so, you create these batches using DStream, and you process each of the RDD using your standard transformations or actions. All right. So whatever code you will write on the DStream. DStream will be executing that code on these batches, the same code on all batches. Let's say you are writing word count program. So it'll count word in each of these RDDs every second or so. All right. So what we're going to do is you're going to do the word count kind of exercise on the using Spark. In case you are looking for almost real time, like lesser than 1 second kind of a response, then you should use something called Storm or other processing engines. Spark Streaming is very sophisticated in the sense that you could do machine learning, you could do all kinds of complex tasks. You could also handle humongous load using Spark Streaming. So the only downside of Spark Streaming is that it is not great for the situations where you want the response time of less than 1 second. All right.
Sandeep, RDD
Yes.
will divide into partitions.
Yes. Internally, this RDD that you see here, it'll have partitions in it and will have elements. So there are so many RDDs being created every few seconds.
So these RDD will be subdivided into further parts.
Yes, yes.
Okay.
All right.
Yeah.
So even if there are 1 million records in a second, you can still handle those 1 million records using the RDD mechanism.
So all these happening in a Spark
Yes.
only.
Yes. So Spark Streaming only breaks down the input data into these RDD, and rest of the logic that you have written would execute against the RDD. All right. Let's take a look. I think a program will make more sense when we do the hands-on, all of us together, then it'll make more sense. A question from Raja is trending are calculated using Spark or Storm. You can use either. If your response time is expectation is in few seconds, then you can use Spark. If less than 1 second, then you can use Storm. A question from Grishma is that in case of streaming, will it go to the same machine or spread across? It'll spread across, depending on the data. So it's like creating the batches of data and then using the sc.parallelize. Okay, it's like that. So all DStream is doing is there's a while loop running, and every 2 seconds, what it is doing is it is gathering this bucket of data, and then for this bucket of data is doing the sc.parallelize, which is creating the RDD, and on which the logic you wrote would run on this RDD. You will write the logic once for DStream, and the same logic will be executed per second or so, or here per 2 seconds. All right, so let's try to solve this problem by doing the hands-on. That'll make more sense and will answer your questions. So the objective of this exercise is count the number of words in the text data received from a server listening on a host and a port. Okay, so there is a server which is producing the data continuously. And what you want to do is you want to read the data from this server continuously and process it. And how do you want to process this? Do the word count every minute or every few seconds. All right. So what we are going to do is we are going to create a service first that produces data. We'll create a producer, and then Spark Streaming will be the consumer of that data, and will consume that data and then would do the statistics or analytics on per second basis. All right, so let's take a quick look here. So here, if in 1 second this data came, like the quick brown fox jumps over the lazy dog. So here it'll basically do the word count. Okay, so this is what's going to happen, and let's take a look. So we'll have two parts of the problem. One is called Spark Streaming code listening to this host and port. So this is the first part, which is the server that is generating data or keep on printing the data continuously. That's what the server is going to do. And this server will work like the producer of the data. All right, so the server is the one that we will create first. Then we'll have the listener who is listening to this data and executing this Spark Streaming. All right, so we have already written this code here. Okay. All right. This is the GitHub repository that we have, and all right, so this is the code. I'm just sharing it with all of you. Okay, so we're keeping it open here, and I'll walk through this code very soon. Now, let me exit full screen. Now this is better. All right, so let's start with this. So first of all, we have this repository already, and I have already cloned this repository for ourselves. If you have not cloned, you can clone it again, or pull the to get the latest data. Okay, so let me just show you while I'm doing it. And here we go. Let me log into SSH Sandeep Giri 9034. You can use either the web console or Jupyter's terminal. I'm going to log into E because E is the one that I'm going to use. All right, so first of all, I'm going to say clone. I've already done the cloning for, right? So here I'm going to say big data. I'm going to remove this part. Okay. And let it be say big data. So first of all, if you have not cloned, you can clone already. For me, since I've already cloned, it says big data already exists. So I'm going to use the second command. I'm going to use the second command, which is for pulling the data. So I'm going to cd big data, and then means if this previous command was successful, then do this. So it changed the directory to big data and then executed git pull, meaning bring the fresh code from the repository. So it's a sequence of two commands separated by ampersand. All right, so this is what we did just now. We pulled the fresh data, and right now this is the folder which contains the project. Now moving ahead, so let's go to this. Let's go to this folder. We have word count.scala and so on. Actually, this is not really needed to check out. Okay. Actually, this is not really needed. You could just skip this whole, and yeah, you could just open this and and run it in Spark Shell. That's all. No worries of pulling. Let let instead of opening in the VI or something, we can actually open in the browser. This was for the days when we did not have the access to the code here. Okay. How do you delete this marker? So the code is here. I've just given you the entire the location. All right, so I'm going to walk you through this. Now, so first of all, start Spark Shell. That is the first thing. Run Spark Shell. Good. So for me, Spark Shell has started. The next thing we're going to do is we are going to walk through this. Okay, walk through this, and all right. So let's walk through this. So we are importing all the libraries of Spark and Spark Streaming. Underscore here means import all the classes from this package. In the Scala, we can create the name of the packages based on or using the folder structure, and it would automatically create the package. So here we are importing these classes, all the classes from this package or this folder structure org/apache/spark, and import the classes from this package. Okay, that's what we are going to do. Is everybody able to type these two commands? No?
Can you paste the command?
Yeah, can you just open this URL? Can you just open this URL in your browser? That'll be easy for you. Okay. Because if I copy paste in the chat, every time the code is going to be lost between the questions. So I think it'll be better to open directly from this URL. Are you able to open, or is there a permission issue or something? So open the Spark shell, wait for the prompt
Yes,
to
I
appear.
have done.
Okay, great. And then we basically start copying these things. All right. So actually, I can just somebody can actually copy paste from this. And all right. So here, these are the things that I have done. Let me also, actually for me, the problem is that when I shift, it becomes a problem between chat. Okay. All right. So now these are the things that I have done so far. Okay. The other problem with the chat is that it kind of sometimes eats the tabs and other special characters. Okay, now let me just walk you through this. So first of all, we are importing. Then we are saying that only show us errors, not anything else. Because if you run normal Spark program, what happens is there's just too much of debug information that goes up. To suppress that, we can generally set the log level. Next is, here this is the important part. Here we are saying that create a streaming context. Just like a Spark context is created by Spark shell, or if you are writing the standalone application, then this SC is what we need to create by ourselves by using the Spark conf object. Now here, the Spark streaming context is what we are creating. So this is the first entry point to the streaming. Okay. Next is the, yeah, here we are saying that create a window of 2 seconds, meaning for every 2 seconds of incoming data, create internal RDDs or create a batch size of 2 seconds. Next is this. Okay, another question from Raju is, can I use Apache Tori? That's going to be difficult. That's something that you can't use for streaming application. All right, now, the next important part is this. Remember to have some other port. For me, it's 9999. You could have 9998. So what we are doing in this line is we are telling a streaming context that contact this particular host at this particular port to read the text. Okay, so we are creating a socket to this remote host. Right now, the host is local, and this is my port. Don't listen to my port because then you will start consuming my data. All right. So here, okay, right now nothing has started. It is just making note of it. Then we are saying words equals line dot flat map. Notice that this lines is not RDD, it's a DStream, but DStream also provides similar methods as RDDs. If you take a look at, say, lines here, lines is a DStream, receiver DStream. You can see it's a DStream, it's a kind of a DStream. It's not an RDD, but it mimics the same behavior as our RDD because what's going to do is it's like a proxy. It's going to call these functions on every RDD created per 2 seconds. Okay, so here we are breaking down each line of text into words using flat map. And then for each word, we are converting it into a pair where the value is 1 for all. Value is numeric 1 for all of the keys. We created key value pair. Now we can use reduce by key because reduce by key requires you to give the key value pairs. Therefore, we converted our word into word comma 1. And now we are calling the reduce by key. Next we are doing the word count dot print. All right. Again, Right now, it has not done anything. Again, word count is also an RDD. Word count is also an RDD. If you, sorry, word count is not an RDD, it is a DStream. And it's basically the way we keep on creating RDDs. In the same way here we are creating DStreams. Now, DStream knows the entire graph of the things that you wanted to do, so that it'll take the entire graph and execute that graph on RDD. Okay. This is an important point. Here we are starting the computation. We are starting the computation. Okay. Now it will start giving the errors. It'll start giving the error saying could not connect to the server, right? Let it complain for some time. Now we are going to open another terminal. Okay, I'm going to open, you should all open another terminal for the producer. Okay, for the producer. This is the consumer, which is consuming the data. Since it is not able to connect to the server, therefore it is throwing the error. We need to start a server which will produce data. All right, now let's start the server by opening new terminal. Since I'm listening on 99, I'm listening on this port 9999, you can create your own server at a different port. All right, so I'm just copying this for all of you so that you can all copy paste. Make sure that you put some other thing in the port number. All right, or you can just copy paste and change this in a notepad or something. Now, once we have created the consumer, let's move ahead to the next step and create the producer. Here we are saying using a command called NC. NC is a popular command, and NC is used to connect to any port on any server or creating immediate quickly a server. Okay. Now let me just.
Sandeep, I don't understand two lines. That lines one, where lines, and above the D stream. Can you go into the code?
Okay. Which
Yeah,
one?
D stream. Above the D stream, socket stream. For 2 seconds, it will.
It is going to create the window of 2 seconds. So whatever is happening here till here, it is going to do it over and over again every 2 seconds.
Okay.
Okay.
Okay. And yeah, lines.
So yeah.
It will.
So every 2 seconds, it's going to read the data from this place. Okay.
Okay.
It's creating a socket, network socket to this host and this port. You should
So
have
this,
different
so
port.
this the data will come from some any other source like Twitter or
Yes,
something.
correct. So right now, here we can create many kind of sockets. Here right now, we are creating our own server. We are going to create our own server from which this will read.
Okay, we will type some text and it will read.
Yes, we will create our own server to listen on this port, and that's what we are doing here by using nc-lk.
Okay, and
Oh,
when we can type some text, it will read and it will consume.
exactly. So
Okay.
now I have two terminals running, one for this, other for this. Okay, here I could say, hi, how are you? And this one would connect to it and print. Okay, so it has printed R1, how1, U1, and hi. Okay, now I could say A again, and it'll just print the, okay. So just a second, it must have computed above. Here it has printed A7. All right. Okay, so this error is continuing. So so I can yeah, exit from console and do it again. All right. Okay, so I'm going to run it again because it was continuously throwing some random error. Now let me just copy paste again. Probably multiple users were connected to my stream. Okay, so actually, David, you actually grabbed the output of mine. That's why it was throwing error. Okay. That's one of the reasons. Okay, so yes. So I could say, hi, how are you? And it'll basically do the word count on this. All right, you can see it's printing the word count every 1 second, well, every 2 seconds, you can see. All right, now let me try to show you something. So there is a command called yes. Okay, what yes does is yes gives the prints on the screen y again. I can show you by putting more. You can see so many y's it prints. Now if I give yes and pass the output to NC, that means it's going to push a lot of y's per second. So you can see it's printing so many y's per second. So it's doing the word count on y, and you can see that it's consuming so many packets per 2 seconds. Okay, so how many packets are there? It's around 1.1 million. Okay, so it's doing the word count on 1.1 million per second. This one is lesser. Now it's 500,000, come down to 500,000 per 2 seconds. Maybe somebody else is also consuming. All right. So here, instead of me typing, I'm using this command called yes, which keeps on typing y again and again. Okay. And I'm feeding it to my NC. NC is giving out to all the listeners. And this Spark Streaming is one of the listeners of my NC. NC is nothing but a dummy server. All right.
Um, Hi, I have a question over here.
Yes, go ahead.
But we need to append the output, right? So this is giving you a fresh output every 2 seconds.
Yes.
But in like our interest would be to append it to the previous 2 seconds, so that the
Not
exact
always.
no.
Not always. So that is something that we'll talk about after some time, that if you want to carry on something from one window to another, how will you do it?
Yeah. So that I know that exactly how are my numbers
Yes,
at the end of, like, say, supposing 10 seconds. That is five
correct.
windows.
Correct. So
All
we'll
right. So
talk about that soon.
for
All right?
each window, right?
Yes.
Without carry
Yes.
forward anything.
Yes.
All right. Thank you.
All right. Wonderful. So what we were able to do is we were able to process so many records per second. And here, for every window, it has kind of reached the limit of GC. Okay, so we can just stop it. All right. Question is, what is yes command? I can't run the yes command because that would terminate my session. Yes command basically keeps on printing y again. It's for people like me who are really lazy, and there is some installer, and for which we want to keep on pressing y again and again, like when we have to agree on terms and conditions. So we want to press y again and again. So instead of that, you can just say yes, and pass it to some that particular installer or something. Yes was designed for that. I'm using yes to produce a lot of y's for many users, for many times. Okay, so you could say more. Always run yes with more, otherwise it will just overflow your screen.
And
All
another
right.
question. What was the poison line over here?
We don't have poison line right now.
So Control Z kills it.
Yeah.
All right, thanks.
So right now we have not designed the poison for this. All right. So Grishma is saying I'm getting error. Since I've killed my command here in NC, so that could be one of the reasons, because you were also consuming from my NC. You were supposed to change this port to some other port and execute this command. All right. You
By
should have
typing yes.
created your own, right? Yes, go ahead.
Yeah, by typing yes, we are passing the text while
Yes.
creating the server.
Yes. So instead of we typing the text, we are just using the yes command to do it for us.
Sandeep,
Okay.
I changed the port number later as I was getting
Okay.
error, but in spite of me changing the port number, then also I'm getting error.
Okay.
And even
Can I
I
take a
found,
look?
yeah, I can share my screen.
All right. Go ahead.
This is what I see.
Just a second. Yeah. So can you just stop everything? So it's actually trying to connect to my port 9999. Okay.
Want
Press
me to
Control C.
contact here?
Control C. Yeah.
Okay.
Now do it again. Do Spark Shell again. Yeah. Okay. Do you have another console running?
Yes, I have.
Oh, can you go to that? All right. So you are running on 9977. Okay.
I changed
Good.
it. I changed the video.
Okay. Now you have to change the code also. Okay. Just copy paste that code into, say, Notepad. Say this Notepad++ or something. And change this port here to whatever port you want. Oh, but that one is running on, I think, 97 or something. Can you take a look, please?
Yeah, 77. Here. Is this the one you're talking?
Yeah, yeah. Yeah, now this is good. You can copy the entire, just copy entire thing. Yeah, Control A and Control C. Or not this one, the other window. Yeah, that's it. Okay. All right, now press enter. Now you can go to the another terminal. Right. Now you can press enter. Type something. Okay, now go back. So it has basically done the word count there.
Okay.
All right. Great. Great.
Does SSC await termination have something?
SSC await termination is basically it's waiting for it to be terminated. Otherwise, it'll just keep on doing the work.
All right. So until you kill, that means.
Exactly. All right. A question from Binta is my consumer terminal is being freezed and stopped and gone back to Scala now. Okay. So the consumer terminal. I see. I see. Can I just take a look? Is it working fine now? Oh, sorry. No. Yeah, you can try again. All right. Is everybody able to do the hands-on with streaming? Do the word count per second? Oh, it has gone to overflow. All right. Did you use yes command? Yes command would overflow the memory.
Can you hear me?
Yeah.
Yeah, can you hear me? Can you see my screen?
Yeah, I can see the screen. I think that the process has been killed by Spark.
Yeah, I don't know
Okay.
why.
Because I think it overflow the memory or something. But did you use yes command
No. Do I need
in
to
the
restart?
console? All right, just copy this into Notepad or something.
Okay.
Okay. Copy the Notepad first. Notepad first.
Let me copy import first.
Yeah, this one, because we need to modify that port to, instead of 9999, we have to use it some other port, right?
Yeah. Oh, I cannot do it.
Okay, it's not copy pasting.
Let me try again. Should be work. Oh, it's freeze.
It's frozen. Just press Control C.
Control C. No.
No.
Still freeze.
Press Enter.
Control D. It's freeze again.
Oh. Okay. Okay.
Don't need to close it as start another one.
Yes, I think that will be better. Okay. Or you can just open Jupyter so that you don't have to log in again or something like that.
It's okay. No. Okay, we'll go here.
Just copy paste everything. I would say that you copy paste that into a notepad or something, change the port number. You need to run the Spark shell.
Okay, I will change it.
Okay, I think you can do it now.
Yeah,
all right?
yeah, I can do it now. It's okay.
All right, great. So, all right, question from David is, I switched ports and everything is working, including yes command. Wonderful. A question from David is, I had to go to big data directory to get anything to work, not to CloudxLab. Okay, so big data is a directory inside the CloudxLab, CloudxLab repository. Okay. Now, question from Raju is, command to execute this program from a file. Correct. We'll talk about that very soon. Okay, that's the next thing. All right.
Can I go ahead?
Yes, go ahead.
I have a basic doubt. The underlying data structure is an RDD, right, for a DStream?
Yes. So essentially these commands that you see from here onwards, right? Flat map, reduce by, these are proxy methods provided by the DStream, which you can which it will delegate to each RDD. All right.
So all my transformations that are applicable to RDDs can be applied over here without any problem.
Generally without any problem, but this Spark streaming takes some time to catch up with actual API. So one or two functions might be different. All right.
Okay, but more or less the same.
Yeah. Say for example, there is no print command in normal RDD. Okay.
But like the majority ones are present, so
yes, correct.
My transformations can be taken care of.
Correct.
Thank you.
All right. Wonderful set of questions. All right. So let's take a quick break, and we will start from here. All right. So I'm back. Should we start now? All right. Great. And wonderful. So should we go ahead? All right. Answering to Raju's question that why would we have these answering to Raju's question that what will we do in the production kind of environment? How will we run it from the file? Correct. So I've created a complete example for you. Okay. I've created a complete example for you. If you have already checked out the code, okay, let's take a look. So if you go to this folder and here inside big data, the one that we checked out, inside Spark, inside examples, inside streaming, we have word count SPT. All right. So let me just show you in the repository also, you'll get an idea there. So streaming and word count SPT. All right. So a question from Rajane, just curious why we are getting out of memory. Is it because we are storing words already in the memory? Actually, the error is occurring while we are stuffing just too much of data per second into Spark Streaming. Okay. If you are running it, so what it's doing is it's basically trying to put that kind of data. And when the executor memory is overflowing, it is stopping it there. So yes command is stuffing just too much of data. All right, that's the reason.
But Sandeep, isn't that the real world case, like where we would just push a lot of data?
That's right. That's right. In real world, what we generally do is we would not use it in the local mode. Instead, we will be using it, say Spark shell, and here we'll be saying Spark shell dash dash master dash yarn, right? So that will, it won't run local machine. Right now, why it was overflowing? Because the local machine could not handle that kind of data. All right, very good question. So, all right, Rajan was able to answer your question. Now, essentially, when it comes, this is exactly the reason why we distribute the load. What we'll do is we do Spark shell dash master yarn, and it will run on the cluster, and it'll be able to handle that memory. Great, wonderful. Now, next question from Binta is, can you try to put a file document from HDFS to stream now? Yes, we'll talk about it very soon. Okay, so we'll talk about that, reading the data from HDFS. So instead of using ssc.socket text stream, we are going to change that to some other method to read the data from HDFS. All right, that'll cover very soon. Now, so this is the command where we have created the entire project. And notice that we have created build.sbt. This is a very simple file. It has only name, the version of it, and Scala version of it. And then here we have mentioned the Spark dependencies. Okay, here we have just mentioned the dependencies on the Spark. We are saying that we depend on 1.5.2 of Spark, and here we are saying that this is a version of Spark Streaming, along with the version. This is the Scala version that we're mentioning, and this is the version of Spark. Okay, now this is the library dependency. So you have to mention all the library dependencies inside build.spt. All right. And here we have created a folder called src. Inside that there's a folder called main. Inside that there's a Scala. And there is nothing else in these folders other than one folder. So it's basically a single line. And here there is a single file inside this. This file is nothing but what we have done earlier, plus one more line, plus basically this particular part. So here we are saying that define a class and define a singleton class using object keyword, and then we are defining the main method, and then we are creating the conf object, and then we are creating the sc object. This part was done by Spark shell for us. Okay. And then of course we close this curly bracket. So this is rest of the program from here till here is exactly same. Okay. This program is exactly same as our Spark shell. So whatever you run on the Spark shell, you can just copy the same thing here and it'll work like a proper program. Okay. Here you can notice that we are creating this SC object. Okay. We are creating this SC object. All right. So you can just go to say this particular repository and walk through the repository. So big data repository contains Spark. Spark contains examples, then streaming, and then we have word count SBT here. And inside it, this is the whole project. So it's pretty simple project. All we have to do is create this kind of a folder structure. This is the smallest project that you could create. All right. Once we have done that, all we need to do is we need to go to the console, go to this folder. You can see my present working directory. So you could use this command called cd and this. Okay. So this is the command to go to this folder. Let me just put tilde. Tilde means home directory. This tilde that you see here, that means home directory, then big data, then Spark, then examples, because I have checked out the repository in my home directory. Okay. So you go to that particular folder and all we need to do here is SBT package. That's all.
Sandeep, one quick question.
Yeah.
I forget. Actually, I write down the slides you have given, but I forget which topic it is. So can we find in my courses all the slides?
Yes.
Or you have any where all the slides are there?
It's basically I think let me. Yeah, actually, you can go through my courses and individual playlist. There is individual chapter, right? Spark streaming and so on.
Yeah.
Inside that, you can find. Okay.
All the slides are there.
All the slides are there, yes. But each slide, basically, or each presentation is inside its own chapter.
But if you find few differences, it was old and this is updated one. So,
okay.
So are there any difference or is the same?
There could be minor differences. I'll just check once more. Okay. Export the PDFs again to ensure they are same. All right. So I'll do that.
Thanks.
Okay. They're going to be very minor differences, not much. All right. A question from, okay, so yeah. SBT package means what? Let me explain. So SBT package is basically going to create our output folder. Okay, it's going to create the jar, it's going to compile, it's going to do everything. These are inbuilt commands of SBT, and SBT package essentially creates the jar file. Or let me just show you SBT clean, and then it'll show you the entire process. So SBT clean is another command which cleans the previously compiled code. So it's going to do the entire process from the beginning.
Sandeep, is that SBT package used for Scala only? Or dot Scala extension?
Correct. So SBT means Scala build tool.
Okay, it's like similar like Java compilation with the Java.
Yeah, in Java we use either ANT, A-N-T,
Correct.
or we use the Maven, MVN. See,
Mhm.
so SBT is nothing but like the brother of MVN. It depends upon a lot of MVN.
Okay.
Okay. Those who are coming from C background, they can take analogy with make. There's a make command. In production, what happens is we don't use the IDE to compile anything because the compilation or packaging, everything happens automatically. Therefore, we need to create our build tools. Okay. Thank you, Rajan. It's a very good point. So Rajan's point is that we need to change the port number before the code. Yes, that's correct. So we need to change the port number in your own copy. All right. And how do you change that? Either you could use Jupyter, or you could use the VI, or let's say Nano, those who are not comfortable with VI. So you could go into this place. So using this, you could edit this here. You could change this. Okay, change this port. Right now I'm using 9999. You could use something else. A question from Hitendra is, what happens when we do Spark Submit of this project build? Okay, so when we do Spark Submit, it's going to run the main method of your code. It's going to run main method of your code, and the main method, what does it do? So when we say Spark Submit on this jar, it is going to execute this particular program because that's the only program with the main method. And here, this will start first. It will create a conf object, then SC, a Spark context object, then it will create, set the warnings to, set the log label to warning, meaning it will only print the statement that have warnings, not everything. Otherwise, there are a lot of text that gets printed on the screen. And then we are saying SSC. Here we're creating the Spark streaming context, and so on. Now, question is, once we are done with it, once we are done with the SBT package, then you will see that it would say that packaging this. Okay, packaging this. It means it has created a folder called target. Inside it, it has created this folder, and here it has generated my output jar. Okay, so we could simply say Spark submit, and here is my output jar. Okay.
Sandeep, SBT will create a jar file.
Yes, SBT package will create a jar file. SBT clear will clear everything.
Okay.
All right. So once I have run my Spark Submit on one window, it's time to connect, and now it's waiting for me to type something. So here I'm saying, hi, how are you? So it's going to print that here. See that? So, okay. So you can see it has computed the word count properly. If I just copy paste this text, for example, will it do something? I just copy pasted some random text. Let's see what happens. Yeah, it has computed this. Okay. And all right. So now here, okay, great, great. Okay, so good. So on one hand, I'll again explain to you. So you went to this folder, right? And what you did was you edited your text, correct? Using Nano, right? And then you did SBT clean and then SBT package, okay? So Nano and edited this. After nano, you can say Control X and save it, right? And let's say for me, if I want to launch it on another port, if somebody wants to do a rundown, I can help them. Okay. So is anybody stuck? Do you want me to help? I can just let you do it. Okay. So here after nano, we have to say SBT clean and then SBT package. And once that is done, we have to say Spark submit. Okay. Then we have to say Spark submit followed by the jar file.
So SBT package will take which jar file? Word count.jar will take.
It will create word count.jar, yes.
Okay.
So this is what it has created. So inside target, this is what it has created. Okay. Once you're done with that, you run the Spark submit. Okay. And then in another window, you execute this. Okay, so let me just write it here so that everybody is clear. So first of all, we did, okay. All right, so first of all, we did git clone. What was the repository? Let me just write it for you. Okay, yeah. Okay, this is git clone. In case you have already done it and you want the fresh code, you could say this, or you could simply say git checkout dot. This will override, the second command will override your changes. Okay. Right. Either you can use this or you can use Jupyter. Thank you so much, Rajan, for this. So you can also use Jupyter to edit this particular file. Okay. Instead of nano, if you don't like nano at all. And then you do SBT clean, then SBT package, then you submit your created jar. And once you're done with that, in another window, you do this. Okay, so this one goes to CD Big Data. Then you say checkout, and checkout means it overrides the local changes. Okay, please keep that in mind. And git pull origin master, it brings the code, fresh code from the remote. All right. Yes. In case, so keep in mind that if somebody has already running something on 9999 port, you will have to use a different port. Okay. So general practice is that you post your port number in the chat window so that other person does not use that port. So for me, it is 9999. You can post your own port number. Everybody should be using different port numbers. Okay.
Sandeep, for me that SBT package command is still running. I think.
Let it run for some time. When you run it for the first time, it basically downloads all the jars that are required for you.
Okay.
All right.
My question is, why are we jarring those files? Because we are already inside the system, right? The location where.
Correct. Good question. So remember that whenever we are using Spark Summit, we might use tomorrow. So we are building it here, correct? So it will go to Spark cluster, right? And Spark cluster may not have these things installed, right? Therefore, it will bundle everything that is needed for your program to run so that you can peacefully execute it in production. Okay. Instead of you forgetting, oh, I forgot one more class file here or there, instead of you doing that, let it package everything.
I mean, all the environment needed for the file.
Yes, yes.
Okay.
Yeah. This is what we do it in the production also, that in any real environment, we actually use this mechanism of auto building. We never use this IDE way of doing it. IDE way is only for code autocomplete and debugging, but IDE is integrated development environment like Eclipse or say what was that? JetBeans, IDEA, IntelliJ, and so on. Right? So those kind of things are used only for the developer's perspective, but in the production or any continuous integration environments, we use always these auto build tools. All right. Great. So I think this you could use in order to that. Question from, okay, David, what was this video about? Ice cream sandwich? Is that the streaming example? Okay. All right. Great. So, all right, is everybody able to do it? Should we move ahead?
Sandeep, even we submit the Spark submit, even then we have to open another window and do NS minus KL.
Correct.
We have to open the producer, correct?
Yeah, that's right. That's right.
Yeah.
Okay, so great. Should we move ahead? Who else? Who has finished doing it? Okay. So I think Bharti Raja, you have. So one more thing, all of you should know that on a Unix system, you cannot have the you cannot run your server. You cannot make your server listen to a port number which is lesser than 1024, right? That's why we generally use 8080, 9999, and so on. To listen on lesser than 1024, we need to be the root of the system. Therefore, keep in mind that if you want to run your programs, make sure that the port is more than 1024. Okay. Wonderful. So should we move ahead? So we were able to do that. There was a question from Rajan. What does this mean? In case you are running locally, you could specify local or to, okay? Or you could say master yarn. If you want to do scale away, let's say you want to run in Python, then you could use this. These are word count example in Python, those who are interested in Python. Okay. So
Sandeep, what does that to mean here?
I'll tell you.
Okay.
So when we are running Spark application could be multi-threaded, right? Because it's just generally a normal Scala program, and each Scala program could have multiple threads. So how many threads to dedicate to this program is what we specify here. So there are many formats to do it, right? We could actually put asterisk. This is safer way. And this is the one that we talked yesterday about. Okay, so let me ask each of you, what's the difference between this? What does this one do? The first one? Or let me ask in another way, are these two same? They are same. Okay, they are same. So here what we're saying is run this program in the local mode. Don't run it on any cluster manager, and give it as many threads as possible. Okay, here we are explicitly saying that give it 2 threads. 2 threads meaning minimum of 2 threads should be given to it because it's going to run Spark streaming program. So it is mandatory that you should specify minimum of 2 threads. Okay, so this is good enough. This is good enough. You don't need to do this. This one is going to run your program on top of Yarn. All right. Yes, 2 threads. So in Java or any other programming language like Scala, the way we used to do parallelization, if you want to run 2 things parallelly, we will create 2 threads. Okay, we'll create 2 threads and let it run in parallel. In the same way, Spark also, while running things, it has 1 thread run dedicated to do the various housekeeping works, and other thread is dedicated to run your program. Okay, that's why minimum of two threads are always mandatory. Okay, otherwise it won't be able to do any housekeeping and it won't be able to run. Okay, so great. Now moving ahead. So here in the SBT, you must have observed that we have specified the library dependencies. This means that this is the package name. This is the package name. This is the one that we are sub package name. Basically, this is the package of package, and this one is the main package that we are trying to use, which is inside this. And here we are saying that this is the version that we're looking for. Okay, this is the Spark version that we're looking for. You can change this to your Spark version, whatever version you are using. All right. So if we are, let's say, if we are processing Kafka, then we'll have to, instead of this, along with this, in the library dependencies, you will have to add this. If we are processing data from Flume, you will have to add this as the dependency, and so on. So all you need to do is, if you are going to connect to any of these, you will have to update your code, as well as you have to update your sbt-conf file, right? So how do you find out these versions? You can actually take a look at the Maven repository, because SBT uses this repository to download the software components. So you can actually go there, whichever, let's say tomorrow there is a new system for which you are looking to connect, then you can say search this central repository and access the various libraries required, right? Here you can see Flume Sync, Flume, MQTT, and Twitter, MLlib, again streaming Twitter, and so on. So there are so many libraries available to you. So you can basically just use these names for this particular version and so on. So here so for searching for anything, you could generally go for search.maven.com and search for this kind of a syntax. All right, that's what it means. And there you can find exact package name which you can use in your SBT file, right? Because in SBT file you noticed this. Where will I find this name? You can go to the Maven repository page and then search for org Apache Spark and the version, and you will get which all artifacts are available. All right. So here is a quick recap. What we did was, first we initialized the streaming context with a variable name SSE. Then we defined the input sources by creating the DStreams. It is defined in the lines variable, where we were defining lines equals to socket something. Then we defined we did the whole word count thing, calculating the words, then pairs, then the word count, right? And afterwards we did the processing using Spark streaming context .start. And then we waited for the termination, so that if they get killed or something, the control comes back to us. Otherwise, it will hang up. If you want to stop the streaming context ourselves, you could explicitly call streaming context.stop. It will stop our process. Okay. Now, for running locally, do not use local and local one as the master URL, because it'll use only one thread for receiving data. There will be no thread for processing the received data. Always use local n as the master URL, or n is total number of receivers. So yeah, so that we have to keep in mind. So for running on clusters, the number of cores allocated must be bigger than the number of receivers. Okay, so here n is that. So generally you don't need to worry about this n. You could simply say yarn and let it allocate as many applications possible for your kind of data. All right, great. So that was our hands-on with Spark Streaming. I'm hoping that most of you were able to do it. Now let's understand what is Kafka. So Prashant's question was that we learn Kafka. I forgot to answer that. So yes, we will learn basics of Kafka. We will learn how to interact with Kafka. And I think Prashant has already left. Okay, no worries. Okay, so Kafka is used for building real-time data pipelines and streaming applications. Kafka is a queue, like a pub/sub queue, and it's a distributed pub/sub queue. Publish as in write, and subscribe as in consume. So it's a producer, consumer, pub/sub, write, read kind of messaging system. It's similar to any message queue or enterprise messaging system, just that it is distributed, meaning Kafka runs on many machines parallelly. Originally, it was developed at LinkedIn, and later it became part of Apache project. It is fast, scalable, durable, and distributed by design. It runs on cluster of one or more servers. Each node in the cluster is called the broker. It stores records in the categories called topics. Under each topic, you can create your own topic, and you can write to it, and others can listen to it. Kafka topics are divided into the number of partitions. Okay, so just like we have RDD partitions, similarly we have partitions in Kafka, and partitions split the data in a particular topic across multiple brokers, right? So that the work can be divided onto multiple machines. Each topic partition in Kafka is replicated n number of times, where n is the replication factor of the topic. So we can define the replication factor of each topic while creating the topic. And there is automatic failover to replicas whenever a server in the cluster dies. So there are many brokers in the cluster. If any of the broker goes down, whatever work was dedicated on that broker is handed over to another broker. There can be multiple topics in the Kafka cluster. One topic for say for example, one topic for website activity tracking, another topic for storing application performance metrics, and so on. So this is how you can think of Kafka cluster. Kafka cluster could have many topics, topic A, topic B. Producer 1 and producer 2 are speaking on topic 1, topic A. Then the consumer 1 is listening to topic A. And in the topic B, there is an interesting thing that's going on. Only producer 3 is producing, and consumer 2, consumer 3, and consumer 4 are listening. The interesting part here is this. There is something called consumer group. So when you have two consumers listening to one packet, say this and this, what will happen is whatever is produced by the producer 3, one copy goes here, other copy goes here. So if producer 3 produced 10 messages, a copy of 10 messages will go to this group and another copy will go to this group. So both of them, this group and this group, will receive 10 messages each if producer is producing 10 messages. All right. Now inside the group, if you have group and there are consumers inside the group, so the work will be divided between consumer 2 and consumer 3 inside the group. Why? This is a technique to divide the work between the consumers. So if you want to launch many consumers in the same group, that means that you want to do the load balancing. Some of the messages are being handled by consumer 2, some of the messages are being handled by consumer 3. All right. Because there's always this question that I like to ask in, say, any interview on big data, that if we produce on a particular topic, will all consumers will receive? The answer is yes. What if I want to do something like many consumers should not have the duplication, right? In that case, you have to create consumer group and you have to mark all the consumers as part of that group. That means the work will be divided and work will not be repeated between the consumers. Okay. So I'll just try to demonstrate this as part of, say, okay, let's say this. And yeah. Okay, imagine that here it's producing A, is producing B, is producing C. Okay, so the consumer 1 would receive A, B, and C. Okay, these are the 3 words consumer 1 will receive: A, B, and C. Correct? Producer 2 is producing C, producer 1 is producing A and B, right? Now here, let's say this one is producing D, E, and F. Okay, so one copy goes to consumer 4, D, E, and F. Okay, I'm trying to put, okay, I made a mistake here. So F will be here, E and D, in the same order in which we are pushing. And here, again, E, F, D will be fed to the whole group. Now, this might get, say, D and E, and this might get only the F. Okay, so the work is divided amongst the members of a consumer group. So, okay, a question from Minta is, can a producer produce the same or different topic? So producers can talk on the same topic as well as different topics. Okay, so you create the topic only once and you keep on speaking on that topic in due course of data generation or in due course of the application flow. Okay, when the events happen, you speak on topic. The topics are created only once. Okay, so before any communication could happen, we have to define our topics.
Sandeep, why are we having multiple consumers? Is it because to make sure the work is done fast?
So here, there are 2 kinds of consumers. Here, consumer group has 2 consumers, consumer 2 and consumer 3, right? Yes. This, we are doing it so that the work get faster, right? Yes. Some are being handled here, some are being handled here. But the consumer 4 is maybe another business unit who is interested in listening on topic B. Correct. Okay, the way I gave you an example earlier. So everybody wants to listen to, say, websites messages, the availability team, email team, fraud detection team, delivery team. Everybody is listening to the website changes. Okay. Similarly, there could be many people listening to same topic.
And another question here, topic A and topic B, are these the something like a memory like allocated particular for particular producer or something?
They're basically like names, like you can see it in memory representation of what should we listen on, right? These are subject. Okay, just like we create a folder that every people who are going to produce file, they're going to go to that folder and put that file in that folder, and other people who are going to read the file, they'll go into that folder and read the file. In the same way, we create topics here. Topics are unique names. Topics are not repeated.
So everything happens across same port here. Topic A, topic B, everything is on same port. Or
Same port as in?
like
So yeah, the Kafka will be basically, we will be talking to Kafka only at the port. Okay. We'll be connecting to Kafka over a port, and we'll ask that, hey, can you give me the messages for topic A or topic B?
how will it handle the traffic in that case if there are multiple producers and consumers?
Right, right. So basically, Kafka has multiple brokers, and those brokers are running on multiple machines. And when we are connecting to Kafka cluster, we are connecting to either of the brokers. Okay, those brokers keep themselves synchronized, and they use the zookeeper to talk to each other and synchronize themselves. Okay, so all the Kafka brokers. So as we talked here, I'll just show you. So if, let's say, in your company, let's say there are multiple machines. On each of the machines, you will be running your Kafka broker. Okay, and there'll be many such brokers on your. These are basically services. And how would they discover each other? By the way of using zookeeper. Okay, they will all write into zookeeper about themselves and discover about each other via zookeeper. Okay, you remember a zookeeper discussion?
Yeah, I remember.
All right, so that's how they work.
Okay.
All right, great. A question
So
from
Sandeep,
how will it?
Sandeep, in consumer 4, it will go to the unique data other than common 3, or it will be duplicate data also.
So come again, please.
Like if there are, for example, DEF constant, and some
Yeah.
DEF is sent to consumer 3 and some DEF we can send to consumer 4, then it also fine?
No. So here, the important part is that whatever data is being produced, let's say we produce one more D, so that D will also go here. Okay?
Both in consumer 3 and consumer 4.
Consumer group this B and consumer group C.
Okay, both it will go.
Yes. So all the groups will receive copy of the whole data.
So topic means kind of broadcasting.
Yes. So it's like basically the way you have forum in which we create a topic and people keep on writing inside the topic.
And broadcast it.
Yes.
Okay.
Okay. All right, Mohammed. No overlapping way. So when we need to divide the work between multiple consumers, we put them in the same group. Okay. Otherwise, they will all get the duplicate data. When we want to divide the work, like here, we want some packets to be handled by consumer 3 and some packets to be handled by consumer 2. Then we put them in a same group. So if there are multiple consumers in the same group, they will divide the work amongst themselves. All right. Question from Minta is, can consumer 2 and 3 have the same amount of topics? They will have to have identical topic to listen to. Okay. Otherwise, it'll be difficult to divide the work.
Sandeep, I got another question here. You said there will be brokers, right? So is it like there are 3 brokers in this example? Consumer
In this
one.
example, no. The brokers are internals about Kafka. This is the
Okay.
data model, right?
Okay.
So Kafka provides you topic A, topic B, and it provides various consumers to subscribe to topic A. Also,
Okay.
consumers can define which group they want to belong, and so on.
Where will the broker come in fit here in this?
So like it is like we are saying that here it is like data model, like in database you have tables, here you have
Okay.
topics, and broker come into picture when we talk about the internal architecture. Who is running this? Internally, this Kafka cluster is having multiple servers who are supporting it. These consumers are internally connecting to the Kafka brokers. Okay.
Okay, I got it. So the topic
All
A
right.
is handled by one broker, like that is my question inside the
Topic, no, actually, as I said, that topic has something called internal partitions. Those partitions are divided into multiple machines. Okay.
Okay.
Each topic has this data, right? The data that you're generating here, internally it will be broken down into partitions, and those partitions are being handled by multiple machines.
So on each machine there will be broker running, right?
Yes.
Okay. No.
All right. Question from Rajan is, where is the group defined? Is it defined the cluster, or when the consumer connect, they define the group? Good question. It is defined when the consumer connects. Consumer says that, hey, I belong to this particular group. So, and that's all. All right. Very good set of questions. So question is, what is JK used for? Let me just close these. And so I drew JK, right, somewhere. Yeah. So since Kafka is nothing but a program, right? So Kafka broker is that program which runs on many machines. Now Kafka comes only in the slaves. Kafka doesn't have a master. Okay. Kafka brokers are nothing but slaves doing the actual work. The coordination they do is by the way of Zookeeper. Okay. So Zookeeper is used as their main coordination agency, and then they coordinate between them based on what Zookeeper has informed them. Okay, to locate how many machines are there and so on. Yeah,
So that's the only purpose of Zookeeper. It has no processing rules at all, just to identify.
correct. So you remember what was Zookeeper? Zookeeper is like a whiteboard, right, on which everybody writes their data and everybody reads the data from. Like you in a sales team, if many salespeople are sitting in a room and they're making calls to people and they want to coordinate if anybody is no two people are calling the same number. So they have hanged a big whiteboard in the room, and everybody who is making a call goes onto the whiteboard and write the number. So that's the role of Zookeeper, so that they don't stamp on each other's feet. All right.
Oh, I think it was covered in Hadoop, and I wasn't a part of the
No,
Hadoop.
you will have
Yes.
access to it. You'll have
All right,
access
in
to
the
it. Yeah.
okay on the portal.
Yeah. So you must finish the Zookeeper. Okay. So Zookeeper
All right,
is basically a central place. You can think of it like a central, what do you call, central folder structure on which everybody writes and everybody reads from. And using that, people, all services can do the coordination. All right. So Zookeeper is strictly for coordination, and Zookeeper is an independent tool. And most of the systems in big data world depend upon Zookeeper. Hadoop, non-Hadoop, Spark, and Kafka, and everybody depends on Zookeeper. So Zookeeper is simply a place where people can write and read the data from. Okay, a very tiny storage, but really fast and very reliable. A question from Hitendra is, I'm mixed up between Zookeeper and Yarn. Yarn is for running the program. Zookeeper does not run anything. Zookeeper is like tiny database, which is accessible to all. Okay. A question from Raju is, Kafka brokers divide the data and sends it respective topic at producer level. Okay, so all these programs, these consumers, when they connect to the Kafka broker, and they connect to say Kafka broker and say, hey, can you give me the data from topic A? Kafka broker either would redirect to another broker or will serve the request of the consumer. All right. So Kafka brokers is basically the process that is Kafka. All right. There could be many brokers supporting the entire ecosystem, and an ecosystem of consumers and producers and topics and so on. Okay. So a question from Vinta is, who has the authority responsibility to define consumers into this specific group? As Rajan has asked, that while a consumer connects, they define the group. All right. They say that, hey, I belong to this particular group. All right. So for Kafka hands-on, here is the code. And we're going to walk through this code as we. Okay. So here is the code in case you need it. All right. So let's try to do the same thing with Kafka also, the same word count. Why we want to keep the word count? Because we all are familiar with the word count syntax. So you will be able to differentiate what has changed between normal job and the Spark Kafka job. Okay, so you will be able to differentiate. So here, what we are going to do is, instead of connecting to our process, the NC was the process earlier, instead of connecting to the NC, we are going to connect to Kafka, and then we are going to run the entire one. So we're going to do the word count. So steps are: publish streams of Ys using yes command to a Kafka topic, and Spark streaming code consumes this stream of Y from that Kafka topic in the batch level of 10 seconds. We'll make it like 2 or 3 seconds. Actually, this is just too heavy for our system. Now, print the number of Y that are consumed. So these are the steps. First, we are going to publish the stream of Y using yes command. Then Spark streaming code consumes the stream of Y from the Kafka topic in the batch interval of 2 seconds and print the Y consumed. Okay. This we have already. Okay. Is this different? Yeah, this one is a clearer example. Okay. Whatever we did earlier, it is exactly like this till here. So see, we clone the repository, then we check out, then we clean and package, and then do the Spark submit. Okay, do the Spark submit, and notice the name of the class. It is optional generally, but you can specify that. Okay, so I'm going to describe that. All right, so here is an important bit. So I'm going to give you this particular copy. Ignore the previous copy. This is the one. This one is the one that we are going to use. And okay, so now once we are done with submitting, then we will create the copy, create the topic, and so on. Okay, and after submitting, then we will run it in another window. Okay, so let's follow this process. This we have already done. Okay, this we have already done. Now let's go to this project. Okay, let's go to this project. So we're going to cd big data. Then we're going to go to this folder, Kafka, and then we're going to do clean and package. Okay, we're going to do clean and package. So it's going to clean the entire project and then going to package everything. Also, before going here, let me just walk you through the example, walk you through this particular piece of code. Okay, if you go to our repository, it would be big data inside Spark, inside examples and streaming, there will be word count Kafka. Okay, here you will notice that we have put the Kafka assembly ourselves. Okay, we have put the Kafka assembly ourselves. All right, so here what we have is this. Now there is an extra file which we have downloaded and kept it in so that you don't have to download it, even though you can actually just package it together. Okay, package as in you can say dash dash jars and then let dash dash packages and specify the name of this package, and that should be good. But here I'm going to show you this extra step. This is very useful. So here inside this word Kafka, this time we don't have any folders. That's completely okay. And we have defined this code here. It has the main method and so on. And also here it looks little strange. Don't mind the code here. So here, whatever the arguments are, whatever are the arguments here passed to it, we are taking the name of the zookeeper quorum and then consumer group and topic name. We're going to talk about it soon.
Sandeep,
Then, yeah.
Sandeep, we are basically the word count is for flat map, which is divided into the space, and then word comma one. What is it? Word comma one?
We discussed it, right? So we are converting each word into key value pair so that we can apply reduce by key.
Okay.
Okay. So this we are converting it to key and value. Key is your actual word, and one is just another value, and we're going to sum up all the ones for each word, right?
Correct.
In the next one. Okay.
Yeah.
All right. So this is a standard word count that we have used earlier also. Now, we're creating the configuration object, and then we are connecting to Spark context. And here is the important part. So whatever we need to, when we are connecting to Kafka, we need to specify the Spark streaming context, of course. And then second thing we need to connect is specify is the name of zookeeper quorum. Where is the zookeeper located? Then which consumer group does this particular this particular consumer, because this is going to be one of the consumers of a topic. And here we are basically saying this. Actually, change it to just 2, right? Just yeah, we can easily change it to _2. That's all. And yeah, where is the topic coming from? This is the topic. Okay. Because this is unnecessary, because let me show you what it means. If you go to Scala, all right. So if let's say we had topic equals SG, okay. So this essentially means this. Okay. Okay. So we need to create a map containing topic and one. Okay. Why we are doing that? I'll explain. Okay, I got it. So here we are saying that this particular line is connecting to via Spark Streaming. We are connecting to Zookeeper. This is the Zookeeper name, and this is my consumer group. And this is the topic that we are going to listen to. And how often we're going to listen to? Every 2 seconds. Okay. And there is one that is specified here. Probably this is the replication factor. Okay. This is probably the replication factor here. All right. So now let me exit from here. So we have already created the package, right? We've already created a package. So here it has packaged our jar. Okay. So we can say Spark submit and run the jar. Okay. Here we need to specify the name of the Zookeeper quorum and so on. All right. So where do we get that information? So this is the way we are going to run it. All right. You can choose a different topic. Here we are saying Spark submit. Okay. So here we are saying that Spark submit, the class name is this, and this is a jar file. This is the input jar files. And we are saying that connect to this particular Zookeeper. Zookeeper runs at 2181 port, and it is running on all of the machines. Okay. And this is the name of the consumer. Okay. Consumer group. And this is the test one. This is the topic that we are going to use. And whatever is the output, let it go to dev null. All right. I'm going to remove that part. Okay, so here we go. All right, it's trying to connect and it'll keep on trying to connect, and it has so far not found any data there. All right, now on the other side, what we are going to do is we are going to in another terminal, we are going to produce data, right? And how do we produce data? By connecting to the broker. Okay, or let me just stop it and we will run it later. Okay, so in the other terminal, on one terminal, we are going to run the Spark submit. Okay, and in another terminal, we're going to talk to the Kafka. So this is an important part. So here we are first of all exporting the path. Okay. This is the file that we are following for our example. Then there is a command called Kafka topics that we can use. Okay. The command called Kafka topics that we can use. It has many options available. We are going to just list all the topics. Okay. Also notice that here we need to specify which Zookeeper to connect to. Okay. We need to specify which Zookeeper to connect to. Okay. So there are just too many topics here. Okay. We can create our own topic. Here. All right. Using the same mechanism, using the same command. Okay. So here we're going to say create a topic called, let me just give you this list command. Okay. So right now we are talking to Zookeeper, and Just give me a second. All right. So on one window, we are going to run Spark Summit. On another window, we are going to connect to the Kafka and create a fresh new topic today. Okay. So topic which we are going to create is, let's say, SG. What was the date today? 29 April. Okay. So that's the topic that we have just created, 29th April, right? Now, we will talk on this topic, okay? We will talk on this topic only using this command, using this topic. So we are saying Kafka producer, and we are talking to, okay? So it says that failed to send request to topic 29 to the Kafka. All right. Two 2181 is the port for Zookeeper. 6667 is the port for Kafka. Okay. So there is some error that is occurring for this particular topic. Maybe it's not able to connect to the Zookeeper. So maybe we'll have to use some other Kafka broker. Okay. So we can just pick any other host for the Kafka. And how do we find out the okay. So ls/this, and here you will find the okay. So let me just show you ls/brokers, right? So inside brokers in the Zookeeper, you can always find your brokers. And here, if you take a look at the brokers, you will see 1, 4, and 0, 1, 4. Okay. So if we say get any of them, that should be good enough. So as I said, that all the information about all the brokers is written in Zookeeper. So here it is showing that the Zookeeper is running on this port, okay, this server. So you could always connect to this one without any problems, okay? Let me just change the local host to some other port. Okay. What happened here? All right, let's repeat this one next week. In the meantime, whatever time you get, please try to repeat whatever we have done today. Okay, let's do that next week. All right. Thank you for that suggestion, Grishma and David. So we will continue this particular example next week. These are more involving examples, and these are more involving examples, and this basically is across multiple components. So it is better that just after this session, you all must try whatever we have done today. We have done a lot of hands-on today, and you all must try this. This will give you a very good understanding of things, and try to tweak and understand each of the part that we have done today. All right.
Sandeep, can we discuss offline for a few minutes?
Yes, yes, correct. Sure. So I will suggest to all of you that whatever we have done from the 1 till here in this slides, you all must give it a try. Okay. Those who want a copy of this presentation, I'm just giving you the copy of the presentation again. Keep this and try all the commands that we have done today. All right. It is very important. Otherwise, everything would look really, really, messed up to you. All right. Because there are multiple components that we are interacting. And in a single work that we have done today, there were multiple terminals opened and we were trying to do more involving examples. All right. So I would suggest that all of you must give it a try till the slide number 51. Okay. So thank you, everyone. I'm going to stay back for next 10 minutes. If you have questions, you can stay back. All right, go ahead, Sachin. You had a question.
Yes, Sandeep. Sandeep, I am working in like one company and I'm doing some kind of administration job. So a little bit of development. So in company's interview question, they ask, what is your day-to-day activities?
Okay.
And yeah, so how we can describe our day-to-day activities?
Okay. You can describe that whatever you are doing, as well as you can describe that you are studying all of this and you have the knowledge of all of this. And you can ask, so the way, if I'm in your shoes, what I will do is that these are the things that I'm doing right now. And I'm interested in working on these kind of things. And that's why I'm applying to your company. And I'm good with this. You can ask the technical questions related to these topics. I'll be more than happy to answer those.
So generally what program, I think word count is a like simple program. So word count they ask and some more, what are the most commonly program they will ask?
Right. So generally, you can't really memorize all the programs, right? But you can practice and try and experiment with more examples. Say, for example, here. So another question that people generally ask in case of Spark is how do you compute average? Then people ask about how do you compute the max temperature or minimum temperature and so on. All right.
So can you sometime give us the list or email us like the program which we can, at least we can look into that before going to the interview?
Correct. You should actually go
Some
through whatever.
Ask.
Yeah. So see, we have a very popular blog on Spark interview questions. I had written it long back. It is being copied by many people. And we are somewhere here. Actually, they even copied my spelling mistake. You'll be amazed to know. Okay. So actually, most of the interviewers actually ask questions from this itself. Okay.
And one more thing, like commonly ask commands, because at the administration point of view, they ask command. For example, they will say how you submit the Spark job. So I will say Spark submit then job. So do you have not now? I'm saying that like, can you give us some like commonly used commands?
So yeah. Here, if you go back to our discussions in the beginning, if you let's take a look at the first chapter that we talked about in long back. Where is the chapter? The S1, right? Is not Scala introduction. We are talking about Spark introduction, right? In the Spark introduction, we had talked about all the commands that are there in Spark. All right. Okay, so here, if you take a look, here we talk about all the commands, you see? Spark Shell, PySpark, Spark R, Spark Submit, Spark SQL. That was the first chapter. Okay, so what I suggest is that as a thumb rule, what I found is that if you just skim over all the PDF you can download and keep it with you, just go through the slides very quickly and you will get the entire context of what we're talking.
Okay.
All right. In case you are not clear about a particular slide, what you can do is you can go to the video and slide quickly to reach to that particular slide, and then you will be able to figure out that what we talked about on that slide.
Yeah.
Okay.
So actually, I have not written according to the name. I have not written. I just copy paste the URL of the slides.
No, actually, you should try to go through this one. Okay. So here, what we have done is, if you go to my courses, right? If you go to my courses here, click on start. And here you can see all of these topics, right? So let's say you want to revise, say, Scala. You can just click on Scala. And here there's a proper exercise here. And let's say resources you go to. There you will get the presentation, okay? And you can quickly take a look at the presentation here. And in case something is not clear, you can go to our class video, keep the class video also open, and that way it'll help you. All right, this way you can quickly go through. Okay.
Okay, thanks.
All right, great. I think that would generally help you review the entire thing quickly. Even today's session,
commands, if we get commands, we can get to PPT, do you mean?
Yes, every command, because you can't really type the command in a single page. It'll be too confusing. Okay. All right. A question from Shravanti is, Sandeep, can you give us a real-time project that can put on your profiles? Yeah, actually, both the projects you can do in the project that we're talking about here, you can actually put in the profile the writing the application. Okay. So here, writing Spark applications, this particular one. And we will give you more projects as you're going, because this one has one project. Today's one where we are going to, we were connecting to Spark Stream, that was a project in itself. And you can write that this is what we did. There was a project statement. And of course, the writing Spark applications, and this one is a full project that you can try. And let me see what we can do, because we are actually going through all possible things that we could write. So again, we could just, because we are doing more than what it is to do the projects, and it's just that we will make the projects for you, and you can use that as a title. All right. So to summarize what I answered, one is you can use log parsing, then MLlib example. We have the project in both of them, as well as you, as well as you can use the Spark Streaming one that we did today. So those three projects you can definitely use. And more projects will add into this. We'll send you an email with the project details. All right. Great. Any other questions? I look forward to see you next week.
Sandeep, also add the image resizing one that we were talking about the other day.
So actually image resizing is something going crazy. I was trying, it is not yet working. If you have ideas, you should give it a try. And what we were trying to do is we were trying to use binary files. We were able to load binary files. Now we need a library that can run on top of Spark. So I was assuming that the Scala image library will work on top of Spark, but that library did not work. Neither did the Java's image manipulation library. So we need to figure out which library to use. Maybe we can use.
I think Python has one.
Maybe then we'll have to call that program via system, right? So those are the system command we have to use in order to run the local programs. Okay, so those things.
All right.
A question from,
Can I go ahead, please? So
yes,
at this moment, can we have, are we ready for the log parsing one?
Yes, you are already ready.
For the log parsing one? All right.
Yes,
So
yes.
give that a
So
shot.
yeah, you should actually try this one. 25th is you have to do this one as well as 29th. Okay. Writing a Spark application and Spark project is these two things that you must do. Start working on it right now. Okay.
All right. All right.
Great.
Thank you.
And all right, great. Thank you. A question from Inda is how to start Zookeeper. You can say Zookeeper - client, and that's all. Okay, you can just press tab and it will show you the suggestions. A question from Robin is, if I pursue the machine learning course, are there more topics there that will still involve Spark? That one will give the Spark ML Libs overview, but will not have Spark as such. Okay, those topics are bit different and more involving towards deep learning. Okay, so that's a very latest course and something that is unique. And we realized that there is no point in going back to the traditional way of machine learning. Therefore, we only pick that subject topics here, which are very much fine-tuned to today's world. Okay, this one has actually the very latest topics, something like as latest as last year. So this one basically has 3 courses. One is Java, one is the Python one that is going for 3-4 days. Then we have the machine learning course. Then we have deep learning course. Okay, so these are the 3 things that we have in this course. All right, so it's a very important course. Okay. Question from Robin, will there be more projects and actual applications? Yes, of course. The standard examples that we are running through these can be applicable to anything. Okay, so essentially the whole thing starts with a project. So here on the day zero, before, just after we go through the introduction, just here we have the project. Okay.
Sandeep, this is a different course, machine learning.
Yes, this is a different course.
When it is going to start?
It's going to start soon in a couple of weeks. Okay.
We can attend the demo class.
Yeah, you can attend the demo class. So it's starting on 13th May. All right. So you can join. All right. Feel free to write our review on Quora, as well as feel free to refer your friends. All right. So thank you, everyone. I look forward to see you next week. If you have more questions, you can ask now. No questions? All right. Thank you, Alvin. Thank you, Bharti Raja. Thank you, Bintao. Thank you, Hitendra. Thank you, Jay. Thank you, Robin. Thank you, Rajan. Thank you, Raju. Thank you, Sachin and Shravanti. I look forward to see you next week.